Hello and welcome. Introduction. In this video, I'm going to show you how to turn an LED on using the serial input. The objective is to turn this LED on when you type an ASCII 1 in the serial input and the LED turns on. And when you type an ASCII 0, the LED turns off. Background and prerequisite. Now, I'm going to assume that you have some knowledge of the ATmega328 USART. That'd be useful because it will help you to understand the code later on. And if you're not familiar with the USART, you may want to refer to my earlier video. That is video number 63. The title of that video is ATmega328 Universal Synchronous Asynchronous Receiver Transmitter, or USART. The USART receiver. Now here is a simplified block diagram of the USART. I've taken this out from this particular textbook here. All right, so in the last 3 videos, I've been focusing on the transmitting part, which is this part here. But in this video, my sole focus will be on the receiving part. And data coming into the receiver buffer comes via this pin here. All right, physically, this is a pin on the ATmega328 chip. So it comes in via that pin, goes into a receive shift register. From this shift register, it gets transferred to the receive data buffer register. Controlling an LED. Here is the code. Right, so the first 3 lines of code, you might be familiar with it. The first one is to include this file here, which consists of all the definition of the registers. And the .csec basically is a directive that tells us the code segment the code is placed in the code segment or the flash memory. And then here the .org tells us the beginning of the program or the code. Now here the next 2 instruction is an LDI instruction. Basically this will copy this value, which is in hexa is FF into register R21, and from R21 copy that to DDRB. That is the data direction register B. Basically this will set port B of the ATmega328 as an output port. Now the next 2 instructions basically copy this value in hexa. That would be 10 into R16, and then from R16 copy that into this register. This is the USART control status register B. Basically this will enable the receiver. All right, so here very quickly to remind ourselves, we're working with this part of the USART, the receiver part. And here is the register that we mentioned earlier, the USART control status, register B. And the bit that we are most interested is this bit 4 here. That has to be set to a 1. This is the RXEN, that is the receiver enable. So you set that to a 1. And then the next 2 instructions basically very similar. We copy this value, which is 06 hexa, into R16. From R16 we copy that into the USART control register C, not B. What does this do? Basically that will set the character size, the number of data bits, the parity bit, and the stop bit. And here is the diagram of the USART control status register C. And these are the two bits that we are most interested in, because this is the thing that we need to set to a 1. And basically these two bits here, we combined it with another bit which is in the USART control status register B. That was the previous register with C. We combined that with a bit called UCSZN2, right? So, but anyway, if you want to understand this further, as I mentioned earlier, please refer to my earlier video. And here we have next 3 instructions. Basically, these instructions basically will set the baud rate of the USART. So we copy 67 hexa in binary, that will be this, into R16, and then from R16 copy into this particular register called UBRRL. All right, and then we clear the least significant LED. Let's take a look at this register. So UBRRL is actually part of a 16-bit register, which is the other half is the UBRRH. H is the high byte, L is the low byte. But in our case, we are using only the low byte. All right, or we are interested in bit 6, bit 5, and bit 2, 1, and 0. So this, using this combination of 67 hexa in binary 11100110, that will set the baud rate of 9600. Okay, so the next 4 instructions here, basically these instructions are there to see if the receiver is ready to receive data. Now, so let's look at this instruction here. So this will this LDS instruction here will copy the contents of the USART control status register A, the contents, all 8 bits, into R16, and then using the SBRS to check for this bit RxC0. All right, to see if this bit is set. Now, if this bit is set, then it will then skip this instruction and then go to this instruction, load the contents of UDR0 into R17. Now, if this is not set, if this bit is not set, this is bit 7 of the USART control status register A. If that bit is not set, then it will then go back to serial read, which is this part here, and keep checking. Okay, before we move any further, let's take a quick look at the USART control status register A, and looking at the RxCN bit, which was mentioned earlier. So the RxC mentioned earlier is this bit 7 here, and this bit is set when a received character is transferred from the receiver shift register to the UDR, which is the USART data register. Okay, so the next 4 instructions here, this will check for the ASCII character 1. So CPI, which stands for compare with immediate, so it will check for this ASCII 1, and BRNE is a branch if not equal. So if the character that's typed is not 1, then it will branch to this part here, the not equal. So if it's not equal, you branch over here, and here we'll come to this in a minute. So if it's equal, it will skip this instruction and then set port B bit 0 to a logic 1. Effectively, that will switch on the LED. So this one will switch on the LED. and then it would jump back to the serial read further up, and then we would do the check again. Now, assuming that the input is not equal to 1, it then branch over to not equal. And here it would check for 0, identical to this, except it's looking for 0. If it's not 0, then it will go back and check it again. It will branch back to the serial read part and check it. If it's 0, it will skip this instruction. It will clear port B, bit 0, and effectively that will turn the LED off. And then finally here, basically, this will repeat the whole process. So the whole thing will be in a loop, just looking for an ASCII 1 to turn the LED on, or an ASCII 0 to turn the LED off. And here, we should never get to this part. If all this previous instruction works, we will never get to this part. Okay, so we're in the ATmega Studio 7. I have uploaded the code or the program, and so let's go build the solution. So one succeeded, no fail, 0 skipped. So that's good news. So let's go to debug, start the debugging and break session. So we've got the yellow arrow pointing to this first instruction here. So this will basically copy FF hexa into R21. R21 is down here, the right hand corner here. So at the moment it's 00 hexa. So we should see FF when we're done. Yes. And then we copy that, the contents of that register R21 to DRB. That's the port B. Okay, so we're in port B. So we should see DDRB displaying FF. Yes, it does. Then with the next instruction where we copy 10 hexa into R16. R16 in the moment here is 00 hexa. So yes, we have 10 in R16, and then from R16 copy it into USART control register B. So let's find USART control register B is here. All right, so let's see. Yes, that's 10, and then we copy. So that basically, going back to this too, that basically enable the receiver. Now we copy here 06 hexa into R16. Watch R16. Yes, we have 06, and then copy it into USART control register C, which is this one here. It's already 06. That's all right. Basically, that will set the character size. That means the number of data bits, the parity bit, and the stop bit. Here we have the next two instructions will set the baud rate. So we copy 67 hexa to R16. All right, R16. Yes, R16 now has got 67. And then we copy that content R16 into the UBRR0L, which is somewhere here. All right, so watch the lower 8 bits here. Right, remember the UBRR is made up of 2 8 bits, and we are only using the lower 8 bits, the lower byte, to set the baud rate. So we've done that here. And then we clear port B. So we go back to port B. It's already clear, but now we will just step through this. All right, so it's clear. Now, here okay, let's step through this one first. So we copy the USART control register, contents of the control register A into R16. Control register A. At the moment here we have 02 hexa. So R16 is here. Sorry, he's here. So yeah, so it's 20. Now to test this one, basically SBRS will test this bit, the RX C0. Basically, that's the bit, the 7th bit, which is this bit here. All right, this is the USART control register A, and the RX C bit is this bit here. So we want to check whether this has been set. Let's go back to so we want to check if that bit is set, then it will skip this instruction to go and execute this one here. All right, so what I need to do is to manually correct this or force this into setting RX, which is this bit here. So if I set this bit to 1, then there's 8 plus 2, that will be an A. So if I just change that, all right. Okay, so go back here. So now that bit, this bit here is set. So what we need to do is to execute. Yeah, so it should skip this instruction, which it does because the RX C bit is set. And then we do this one, that will send this to R18. And then we come to R7, CPI R17. Basically, this would check for the input at the serial input, whether it is a 1 or a 0. So let's assume that it's, nothing is happening, nothing is typed, so it's not 1, not ASCII 1. The quote here, this denotes that this 1 is an ASCII character 1. So let's assume that nothing is typed or input. So watch this, it will skip this not equal, go to this part here, not equal, to check for 0, ASCII 0. Let's assume that nothing is done also, so it will then skip and then go back to the beginning to the serial read portion. Now, once we get back here, we go to step through this. I'm going to change this to A again. Just a minute. It's a bit tricky here. Oops. Sometimes it's not that easy. See whether it works. Okay. Change that to A. Yeah, it does. And then now we come down. This is because we're looking at the RX bit, the RX C bit. If that bit is set, then it will skip this instruction, which it did, and then come to this part. Now we execute this part. Now this part we come to check the 1 for our ASCII 1. So this time ASCII 1, the hex value is 31 in hexa. So we go to 17 and we type in 31. Oh, a bit tricky, this part here. I still haven't mastered this yet. All right, okay, so we got 31 here. So that means that's a 1, ASCII 1. So let's see what happens. So we now, so this time it will skip this, set port B bit 0 as a 1. So that will turn the LED on. We will see that later on. So, and then go back, check again. And here, if I just type in A, oh no, it's like one of those things again. Right, so that's set. All right, so now it's all. Let's check for the 0. Oh yeah. So we are now back here again. Aha, I think I now got it now. So go down here. Right, so what I'm going to do here is to change that to 30. 30 is the hex value for the ASCII 0. All right, so this one it will fail, right? So so we come down here now, because it's already set to 0. It should then clear port B. All right, should clear port B here, and then go back and repeat and keep checking for ASCII 1 or ASCII 0. Any other character that you type in will not be accepted. So this, so this portion of the code will keep repeating itself, checking for either a ASCII 1 or an ASCII 0. Hey, so I'd just like to clarify something. The reason why I have been using the manually changing the contents of the what do you call the registers like R16 and the ASCII and hex value is because in the simulator mode we can't use the debugger or the debug mode to single step it. I haven't found a way of doing it yet, so that's why I've been manually changing the contents of the registers and the values of the ASCII code and so on. Now, to test the code, we require some hardware. Here is the circuit that we need to build so that we can interface it to the Arduino Uno. It consists of a LED, and the anode of the LED is connected to the Arduino pin 8, and the cathode of the LED is connected to a 220 ohm resistor, and the other end of the resistor is connected to ground. Now here is a wiring diagram. Here is the Arduino Uno, and I have using a green LED. You may wish to use some other color. And here's the resistor, and here's the ground, and this is the Arduino pin 8, and it's connected to the anode of the LED. And the cathode of the LED is connected to the resistor, and the other end of the resistor is connected to ground. Okay, so for this part of the demonstration, I've uploaded my code in the ATmega Studio, adjusted a little bit, and then I also have my camera, my webcam on, and here is my green LED connected to the Arduino Uno. So the first thing is to I've already built the solution. It was successful. So what I need to do now is to go to upload the code, and when I upload the code, watch these two LEDs. I hope you can see it. It will flash, it will blink, indicating the code is uploaded. So let me go back to the ATmega Studio here. I will click on this to program the I've got a problem. It says it can't access COM4. Now that's because I've already got, I need to disconnect this first, the data visualizer. So it's disconnected. Go back to the code and then upload it again. Watch these two LEDs here. Yeah, it's blinking, and the upload is successful. So let me go back now to the data visualizer, connect, and let's focus on this part here. Let me see if I can. Hope you can see this. So now my cursor is flashing on the serial input. Now remember, our ASCII 1 will turn on this green LED. So I'm going to type 1, and then I'm going to press enter, keep an eye on the green LED, and it's on. Now I'm going to type in ASCII 3. Remember, it shouldn't do anything at this stage. Yes. Let's try another key and ASCII F, enter, nothing's happening. So it will not, the only key that would accept to turn an LED would be ASCII 1. Now to turn the LED off, we need to type an ASCII 0. So I'm going to type in the 0, press enter, watch the LED, and it goes off. Now let me just try any other key, a D, and nothing happens. Let me try another one, a C. Okay, so let me type a 1 to turn it back on, and a 0 to turn it off. One more time, a 1 is to turn it on, and a 0 will turn it off. Hey, that's all for this video. I hope you have found it useful. Thank you for watching, and I've uploaded the code that I've used to the link in the description. So if you want to try it out, please feel free to download the code, and hope to see you in the next video. Okay, bye.